Hi, today we are discussing process memory and operating systems. A process is an instance of a program in execution. It includes the program code and its current activity, represented by the value of the program counter, the contents the process is registered. A process also includes a stack, which contains temporary data, a data section, which contains global variables, and a heap, which is used for dynamic memory locations. Importance of process memory in operating systems, resource management, isolation, concurrency, protection, multitasking. We will discuss this in detail the next slide. Resource management processes allow the operating systems to manage resources such as CPU, memory, and input-output devices efficiently by scheduling and controlling the execution of programs. Isolation. The process provides isolation between programs running on the same systems, ensuring that one process cannot interfere with the execution of other. Concurrency. Process enable concurrent execution of multiple programs, improving the system's overall performance and resource utilization. Protection. Process may enforce security boundaries, preventing unauthorized access to resources and data by different programs. Multitasking process enable multitasking allowing users to run multiple applications simultaneously. Basic concepts and structures of a process environment. Process control block, a PCB. A PCB is a data structure used by the operating systems to store in all the information about a process. This includes the process state, program counters, CPU registers, memory management information, accounting information, and input and output status information. Process state. New. The process is being rated, running. Instructions are being executed. Waiting. The process is waiting for some event to occur. Ready. The process is waiting to be assigned to a process. Terminated. The process has finished with execution. Memory layout of a process. Text segment contains the executable code. Data segment contains the global and static variables. Heap used for dynamic allocations. Stack contains function call information, local variables, and return addresses. Process scheduling. The process system uses scheduler to determine which process runs at given time. Scheduling policies such as first serve, shortest job next, or round robin are used to allocate CPU among other processes. Inter-process communication, also known as IPs, process processes may need to communicate with each other for various reasons. IPC mechanisms include shared memory, messages passing, semaphores, and signals. Diagram of process memory layout. Stack, which grows downward, heap grows upward, data segment, and text segment. Sections of a process in a memory. Command line arguments. Description. The arguments are passed to the program when it is executed. The role of these arguments allows users to provide input values to or options to the program at runtime, influencing its behavior or output without changing the code. Text. The section where the program code is stored. This section contains the compiled machine code instructions that the CPU executes. It is basically read-only to prevent accidental modification. Contains data. This contains global and static variables. This section holds variables that are initialized and maintained throughout the program's execution. It is divided into initialized and uninitialized VSS sectors. Stack. Used for local variables and function call management. The stack stores temporary store data such as local variables, function parameters, return addresses, and heap manage functions and returns. It operates in last in, first out. And heap, used for dynamic memory allocation. The heap provides memory for variables that are dynamically allocated at runtime. This memory is managed by the programmer and can grow and shrink as needed. Program counter holds the address of the currently executed instruction. The program counter keeps a track of the CPU's current position in the instruction sequence. It increments to the point next instruction, ensuring the program executes in the correct order. Register status contains the value of CPU registers. Registers are small, fast storage locations within the CPU that hold data being processed, addresses, and execution flags. The register status includes current values of these registers, essential for all the CPU's operations. Thank you.